Hey everyone, I hope you all are safe and doing good. So, in this lecture, we will see few more lead code questions on arrays. One is easy level question and one is little bit hard. So, first we'll see what is the easy question, lead code question. It's lead code 27, remove element. First, understand the problem statement. That's very important. So, now you are given you are given a integer array nums and int a value. Well, so you are given a value and a array. You have to remove all the occurrence of whatever value you will be given from that array in place means within that same array itself. You cannot take a separate array. Maybe sometimes you can do like we have an array something like this. Suppose I have an array 1 2 2 3 5 and I will give value is equal to 2. So what you will do? You will iterate the array from here to here, and once you get the value element which is not equal to this value, you just take that and you take a separate array and you just put here 1 3 5. But you cannot take a separate array, you have to do it in place means within the same array. You are not allowed to take a separate array. That is one condition. Okay, fine, now you got it, this condition. The order of the elements may be changed, right? Then return the numbers of element in the nums. So if I have the same 1 2 2 3 4 and my val is equal to 2, so I have to remove these two. So at last you have to return the number of elements in nums which are equal to, sorry, which are not equal to val, which are not equal to val. So in this case 1 2 3, three elements are not equal to, because val is my 2, so I have to remove this 2. How many elements you will get at last? 1 3 and 4 remaining elements, basically, which are not equal to this 2. So that is 3. So this k you have to return, this count or k, any value, any you can say variable name you can take, right? Now the order of elements may be changed. So if you do something, how you will do that thing? What is the approach comes in your mind first? So let's first read the next statement. Consider the number of elements in nums which are not equal to val be k. Let's take k. To get accepted, you need to do the following things. Change the array nums. This is my array and you have to change this array only. This array only. You have to change this array such that first k elements of nums contains the elements which are not equal to val. So the first k elements, k means whatever elements which are not equal to this val, three elements. So first 1 2 3 4 5, five elements are there. So first three elements of this array would be elements which are not equal to val. So it's like 1 3 4. Here whatever elements are there, it doesn't matter. The remaining elements of nums are not important, as well as the size of nums. So the size of nums and the remaining element doesn't matter. But the first k element should be whatever the element which are not equal to this val. That is for sure. At last you have to return the k. K means here 3. How many elements are there which are not equal to val? Basically we are removing the duplicates kind of thing. So it's not like that from this array just remove this thing and all. No. This line is important to understand. And at last return k. Return k. Okay. I hope you got this. So what approach comes to your mind at first? We'll think first like it's not that much tough. It's easy. It's very easy. So how we will approach this problem? See, this is my array nums. Suppose this is my array nums and I want this thing like 1 3 4, and the order doesn't matter. Here it can be 1 4 3, here it can be 3 1 4, any order can be anything. But the thing is, first k element must be whatever the elements which are not equal to val in this array. That thing is important, right? So obviously if you have to traverse, you have to traverse the array from here to here, right? To delete the element or to check which are not equal to this val 2. Maybe here we also you have to. So we have to traverse from here to here at last from 0 to. So basically first pointer we need I from 0 to whatever the length of the array. Suppose length is n minus 1. That is for sure, right? You have to change in place. That is also sure. You cannot take another array. Now, see, at first we are here. I is here. 1. Check. Is this 1 equal to 2? No, it's not equal to 2. So, it should be in this array, right? So, maybe we can take another like k variable. K is at starting, it's 0 or count you can take rather than k. But here they are saying that k variable you are taking. So, same I'm taking k, or count also you can take. At first, it's 0. Whenever you get the whatever the variables which are not equal to this well, as soon as you get, we will keep increasing my count or my k variable. At last we will return this k value. That's it, right? So that's why at first k is equal to 0. It's not just a variable, it will act something like a counter also. So let's see how. So at first we are here, I is here, first pointer, k is, we know 0. So this is not equal to well, right? So this exactly I want. As soon as you get the first or the next known well element, we have to keep this at starting of this array, right? So keep it here itself because it's the first element. So we'll keep it here itself, right? So what we can do is we can do something like this. We can check if we are iterating from 0 to n minus 1, if this nums of I not equal to well, see, not equal to, in that case what we will do, whatever the element is there we put here itself. So basically, and then yes, increment my k. So basically at k, 2 pointer are there. One is to traverse, one is slow pointer that will not move fast. One is fast, traversing here. So basically slow and fast 2 pointer. Don't get confused in slow and fast. Just take 2 pointers. So what I do is I will just write here nums of k. Nums of k is equal to nums of I and k plus plus. Something like this. So nums of k, nums of 0 now is equal to whatever nums of, right now I is also 0. So it is also nums of 0, it is also nums of 0. So means 0, 1 would be here itself. But k is now 1 because we got one element which is not equal to this 2. This thing we need to remember, na? We need to return it last. Okay, fine. Now go for the next iteration. Now I becomes 1. Now we are here. The pointer is here. 2 is equal to 2. Do you need something here? No, just skip it. Because at the starting of the array, I don't want this element. So I don't want to do any k plus plus, or I don't want to store this element. Just skip it. Go for I plus plus. I becomes 2. So now we are here. It's again equal to well. We'll not do anything. Once you find out the next element which is not equal to this well, yeah, that's 3. At index 3. Yes, it is not equal to this. I want this. So what we do is we put this 3 here. We actually put this 3 here because we want this thing at the last. The first k position would be whatever the elements which are not equal to well, that we want, right? See, first k elements of the nums contains the elements which are not equal to well, right? So I want this 3 here. So what we do? Right now we are having k is equal to 1. If not equal to this, not equal to well, yes, this condition true. So whatever the nums of k, like nums of 1 here, k is still here. Now my I is here. So at this place, just put whatever the current element right now. So now this will be 3. Fine. Iterate next. And k plus plus. Now k becomes 2. We got 2 elements now. 1 and 3. We are not taking another array. We are just modifying this array itself. Now I is equal to 4. Now we are here. I is equal to 4. So we are here. I is here now. K is still here. K is 2. So k are here. K is here now. Because we got the first 2 elements, 1 and 3. This is also not equal to well. So that's exactly what I want. I want this 4 here. So same I can do this thing. Same k plus plus. K becomes now 3. I plus plus, I becomes 5. So now I is here is equal to val itself. So don't do anything. We don't want this element. So we don't want to replace this thing or k plus plus. No. Now next iteration 6. But this is like out of this. So loop is now terminated. And now we are having k value at last is 3. So return k. And that's exactly we have 1, 2, 3. 3 elements are there which are not equal to this val. Just simply return k. So I guess you got it. You just need these 3 or 4 steps. That's it. Right? And at last in this array now, we are having after modification, we are having 1, then we are having 3, we are having 4. And here we are having 1, 2, 3. Here we are having again like 3, 4, 2. So it doesn't matter what we are having here. The remaining elements of nums are not important. So it doesn't matter. We are worried about the first k elements only. And that's we got. So that's the simple logic. If I tell you how to calculate the time complexity, one loop is there from 0 to n. In one traverse itself, we are getting everything done. There is within this no for loop and all. So how many comparisons are there? We are traversing this only one time for like each element. So it's order of n. That's it. How many times these steps would be executed? Order of n itself. Right? And space complexity is also order of 1 because we are not taking any extra space or extra array. So that's it. This is how you can remove elements. Let me show you and submit it. So we have just created a new package here, LeetCode, and within this package, let's create a new Java class and let's name it remove element. LeetCode number is 27. So let's write down here 27 remove element. Now, so we have a remove element, suppose method. So let's define it first. Let's make it static and it will return the number of elements. So return type is int and the name is remove element. So it will accept one is array and one is whatever value is there. Now at first, let's take, we are having int k is equal to 0 at first count, and then first pointer is k is equal to 0, next pointer is I is equal to 0, and it will move till n minus 1. So whatever the length of the array. So we don't have to write any n or this kind of thing. Just calculate nums dot length. That's it. And I plus plus. Now check if this nums of I not equal to, if it's not equal, then only we want that number. If it's not equal, well, then only we want that element, and that should be at the front of that array only. So we just put something like this, nums of k is equal to whatever the right now whatever known value you get, just replace it with this and do k plus plus. That's it. Just repeat this process for all the numbers which are not equal to well. That's it. And at last, simply return whatever the k not equal to, so whatever the value is there. So we just write down this in system.out.println, or you can just take a separate variable result and store the output of this in that variable and just print that variable. In this case, if you run, then it should give me 1, 3 and 4. So 3 only. So it will give me 3. If I change it something like this, if I have here 6. So if I run this, then you get here 4. 4. Because there are 4 numbers which are not 2. After removing this 2, because val is 2, the numbers are 4. And if you want to check right now what is this array, I mean if you want to print this array, so we can simply print arrays dot toString and just pass nums. So you will see this array would be something like 1, 3, 4, 6, 1, 3, 4, 6. Whatever the numbers which are not equal to 2, would be at the first k position. So 1, then 3, then 4, then 6. After that, it doesn't matter what we have, 4, 2, 6. Whatever is there in this array, that exactly we have. So it doesn't matter for us. 1, 3, 4, 6 we are having, and 4 is the answer. So that is the only thing which matters. So okay, this is just it's not required that you have to print this. You have to print only that number of elements itself. I hope you got this. So now you can dry run this and you can check yourself, right? Okay, so the next question is LeetCode 169, and this is one of the, you can say, the most favorite question of interviewers. How to find out majority element. We will see step by step all the approaches, brute force, then better, have to optimize that, then the optimal solution and all. 3 or 4 approaches we will see here. So I'll tell you how to like proceed in the interview if they ask this kind of question. Okay, the question is majority element. So you will be given an array, right, of size n, and you have to return the majority element. So it's like something like this. You have the majority element is the element that appears. See the condition, that appears more than n by 2 times in the array. That would be the majority element. You may assume that the majority element always exists in the array. This is the condition. So it's not like that you will not get a majority element. For this question, the condition is one majority element you will get. I mean, majority element always exists in that array, right? You will get majority element if you follow the correct approach. And we know the majority element is, if in array we are having 10 elements. So greater than, which appears more than n by 2. N by 2 is 5. So the element which is in that array appears more than 5. That is, if an element is 6 times, at least 6 times, then that would be the majority element. Yes, if say 11 elements we are having, so 11 divided by 2, it would be again 5 itself, 5.5. So we'll take the floor value, floor. So the 5. If it's sealed, then it would be 6. So same element which is more than 5, that is 6, that would be the majority element. Okay, fine. See the example. Array is 3 to 3, so output is 3 because majority element is 3. In this case, 2 2 1 1 1 2 2. Majority element is 2 because how many elements are there? 1 2 3 4 5 6 7. So 7 by 2, it would be 3. More than 3, at least 4 times. So we are having 1 2 3 4. 2 is 4 times, but 1 is only 3 times. So 3 is not 1 is not a majority element. 1 is only 3 times, but it should be greater than 3, right? What approach comes to your mind at first? How to approach this problem? What do you can say, let's take this thing only, right? Brute force approach. We don't know anything. We are simple the naive approach. I'm just telling you. We don't know anything. We are beginner. How do you think? So simple approach is, we know here n is 7. So we can easily calculate n by 2. That would be 7 by 2. That would be 3. Okay, fine. That we got n by 2 kind of thing. Now we take first element 2 and count how many times 2 is there. If the occurrence of 2, the count of 2 is greater than 3, this is my majority element. And only one element you get, majority element. Again, you take next element, that is 2 itself. Again, third element 1, count how many times 1 is there, compare with this and check. Again, go for next element, count the occurrence of that element in the array, check with this. Again, next element. So we will do this process for all the elements. We'll count occurrence of all the elements in this array. Yes, because if suppose array is something like this, 1, 2, 3, 4, 5, 6, then something like 6, 6, 6, 6, we have 7, 7, 7, 7, 7, and we are having a long array. So for each element, you have to count. For 1, count how many times 1 is there. For 2 also, for 3 also. And after counting, check if it is greater than the length of the array divided by 2 or not. If yes, yes, that is the majority element. Yes, but that's a lengthy process, na? How to write this thing? Obviously, we need first to traverse from this to this. We need a loop. I from 0 to whatever the n minus 1. Outer loop. So one pointer is suppose I. It will iterate through this. Now first we set first element, and for this element we check, we count this in this array, this element exists or not. Then for next element, from starting itself, we count if this element, how many times this element is there, not exist, how many times. Then for next element, again from starting we will start, and from the end till the end we will check how many times this one is there. So basically we need two pointers or two things. One is for every element trace, you have to trace from 0 to n minus 1. Next is we need to hold the element at one, at first element, then second element, then third element. So basically we need two loops, nested loops. Next loop. So at first here we can say that suppose here I am having int count. Count is 0 at first, and we can have assume that majority element. I can just write here majority element is equal to first element. I just assume first is the majority element. So whatever the name of the array, nums and I. Because at first I is 0, nums of I, nums of 0 is, I am assuming that this is my majority element. Yes, at first count is 0. Now I will count how many times my first element is there in this array. So for that, again a loop. J would be from 0 to n minus 1 again. And within this we check if my majority element equal to whatever the nums of j, with every element we compare. If this is the situation, then we do count plus plus, something like this. Count plus plus. Yes. So after once I is 1, then count is 0, majority element is 2. Then again we will enter into this for loop. J would be from starting. Now j is also here 0. Condition true, yes, enter here. Now check. Is this majority element is my majority element is right now I'm having 2. Is this equal to nums of j? J is equal to 0. Yes. So count plus plus, count becomes 1. Again j plus plus. Still condition true. Majority element equal to nums of, now j is here. Yes, it's 2. Again count plus plus, count becomes 2. Now we are having this element first. Again j plus plus. So now we are here. Majority element is 2. Is it equal to 1? No. No count plus plus. Next, is it is equal to 2? No. Is it 2? No. Is it 2? Yes. Again count plus plus, so that is 3. Again count plus plus, that is 4. And now j plus plus. Now we are out of this. So this for loop will terminate now. We are still within this outer loop. This inner for loop will terminate. At last, now we got count is equal to 4. Now check. After this loop, within this outer loop only, check if my count is greater than, not equal to, greater than whatever the length of the array divided by 2. If this is the case, simply return what the majority element in this variable, whatever I am having, simply return my that thing, majority element. That's it. Simple. And close the outer bracket. So after the first for 2, now check if count is greater than n by 2. Yes, it's greater than, so it will return majority element is 1. But suppose if it's not the case, I'm having 1 my majority element. So at last, this count would be 3 only. 3 is not greater than 3. So this condition will not be true. Now we will do I plus plus. Now I becomes 1. Now I is here. My I is here. Condition true? Yes. Again enter here. Count again would be started from 0, because now we are counting for this element, for second element. Majority element is now nums of I is equal to 1. So this 2 is my majority element again. Right? Again now this loop will run from here to here. If This is equal to 2. We will count plus plus. So same for 2, count would be at last 3 itself, 3 only. This condition will not be true again. So again I plus plus. Now I would be here. I becomes 3. So I would be here. Now for 1, same process would be repeated. And this j would be from here to here. 1 would be 1, 2, 3, 4 times. So that condition, if condition, you will get it true and it will return 1. But this is brute force approach. See, for every element, we are iterating the array from starting to ending. It's not a good approach. Time complexity would be the outer for loop, 0 to n. So order of n. Within this, the inner for loop again, the statement would be n times. So it's n into n. We are nested loop. We are in nested loop. So it's order of n square. It's definitely not good, right? Space complexity would be order of n only, but this is not good. Maybe now interviewers say that, okay, I'm not satisfied with the solution. Can you optimize it? So, okay, you will think and say, yeah, I can do that. So this is the first approach. I guess you can easily code this. I'll show you the code as well. But dry run of this says, I guess you got. Now let's go for next approach. Now, one thing we can do in second approach, a little bit better solution is, we can first sort the array. Yes. And whenever you sort the array, sort the array, then if in this array the majority element exists, then there will be two or some cases that maybe after sorting, suppose we are having an array and one element 1 is the majority element in that. So 1 is the smallest element, let's say, right? So that would be here, somewhere here at one place itself, because we have sorted the array. Suppose that majority of element is the largest element, so that would be here at last, but at one place because we have sorted the array. Yes. Now maybe that element is not the greatest or the largest, maybe somewhere between. So here, maybe rather than in between, somewhere else, maybe here or maybe here. So these cases can be there, right? What is common in this case? After sorting, one thing is for sure, I guess. Pause the video and think about that. One thing is for sure, the mid element would always be the majority element, because majority element is what? The element whose no, or which exists more than n by 2 times in that array. More than n by 2. So if array is of a size 10, then if an element is should be at least 6 times present in that array, then only it can be majority of element. So if it is 6 times, then definitely, if here from 1 I just write 0, 1, 2, 3, 4, 5, 1, 1, 1, 1, 1, and 6, 7, 8, 9. So here suppose I'm having maybe 2, 3, 2, 2, something like this. So the mid element is 0 plus 9 divided by 2. So that is, I guess, 4. 4. Mid element is 1. So mid element would always be the majority element if this is the greatest. Suppose I'm not having this. So 1, 2, 3, 4, 2, something like this. And we are having element 4. 4, 4, 4, 4, 4. 1, 2, 3, 4, 5. 6 time it should be. It must be 6 time. So 4 and 3. 1, 2, 3, 4, 5, 6. If elements are 10. So definitely the mid element is again the majority element. You can take any case because it's directly seen that majority element should be present more than n by 2 times, more than half of the array. So definitely majority element would be in the middle. So do one thing, sort the array first and return the whatever the element at the mid of that array. That's it. But sorting also requires the best sorting technique requires order of n log n time complexity, quick sort and merge sort as well. It's not also that much good. but we haven't discussed sorting. So we will not write down a separate logic for sorting. We will use inbuilt method. What is there? Sort in arrays dot sort, and we'll just sort that and then return the mid. But yeah, it will take order of n log n at least. It's better than n square, but not that much good. Maybe you can think one more better approach than this. Think about this. First two approaches are this. Next, think about one more approach. So one more approach can be, see, we are having this thing. This array is there. Suppose this is my array. So I guess we haven't discussed Hashmap. Maybe for those who have some idea about Hashmap. So there we store values in key and value pair, in pair, key and value of that. So we can have a hash map. We can create a hash map. There we use hash table. So in that hash table, what happens? Although we haven't discussed this thing, so you can just leave this approach for now. But we will see hash map soon. So then you will get it. So there would be a table, and there we store key and value pair. So we'll traverse this from zero to last. We'll take first, and we'll just use a map or hash table. There we are going to store the values. So first key is 2. Value means, let's say the occurrence of this 2. Right now 1. Go for next. It's 2. So there no duplicates are allowed. So 2. 2 is already there. So increment the value 2. It's value key value pair basically, but we can take key and frequency or occurrence or count. Anything you can take. Right? So now 2 is 2. Now 1. This is not present. So 1 and frequency or the count is also 1. Now next is 5. So 5, and here also occurrence of this 5 is 1. Again 5. So rather than storing one more pair, increase it by 2, 1. Again 1. Already 1 is there. The key is there. So increment this value 2. 2. 2 is there. So it will become 3. Again 2. It will become 4. Again 2. It will become 5. Again 2. It will become 6. And that's it. Traversing is done till the last. Now we have my hash map or hash table. Now you have to traverse this hash map, and you can get easily according to the key, whatever the value. Whatever the value which is greater than n by 2, return that. That's it. So we can easily check it's 6, which is greater than n by 2 here in this case. So we just return this key, and it would be 2. Here it takes, we traverse from this to this. So order of n, one time, right? And like, but in this case we are creating another hash map or a hash table. So we take extra space, and almost we are storing, suppose extra space, maybe in worst case every element is different, so we have to store all the element 111. So it's order of n itself. Space complexity, although we have reduced order of n, but sorry, time complexity, but space complexity is increased. It's order of n. Now what they need, a solution which has order of n time complexity and order of 1 space complexity. So that is, you can say, a more optimized solution. If you didn't get this, don't worry, because we haven't discussed hash map yet. We will see hash map, and then you will get this thing better. But for now, I'll show you practically. Simply, I will write on the program and I'll show you, okay, a simple working. Briefly, I just told you that this is how hash map working. This is what hash table is. We store key and value pair and all. So directly, if you want to fetch anything, according to the key, you can fetch the value. There are different methods in map. I'll show you 2 to 3 methods which we use to solve this question. Right? So this is one approach, one more approach. Right? And see, they ask, could you solve the problem in linear time and space is order of 1? Order of 1. Think about this. Let's see. What you need to find out, majority element. And generally, when you need to find out majority of anything, then one thing is for sure, voting. We do voting, right? Like more votes, that could be in majority. If in like maybe in for a candidate get more votes, then he or she will be in majority and he will be like elected or something like this. So we do voting system. Majority wins. Yes. Same, you have to find out majority element. So we need to do some voting kind of thing here. So there is a algorithm, Moore's voting algorithm. But obviously, you have to, like you can say, you have to aware about this algorithm first. It's not like that at the same time only you get that, okay, there is some, I can do this kind of thing here. Maybe it's not possible at interview kind of time, because that is a stressful situation and you will not able to get the optimized solution. So better to have some idea of these algorithms, few, you can say, those popular kind of algorithms. So better to have idea of these algorithm first, and where to apply these algorithms, what are these algorithms. So what is this voting algorithm? Suppose this is my array and here I'm having n is 1 2 3 4 5 6 7 8 9. So n by 2 is divide by 2 and it will become 4. So greater than 4, like at least 5 times an element should be there to be a majority element, right? Let's see. We are having the current element, then majority element me, then vote or count, whatever is there, something like this. At first, and let's take index is also there. At first, we are having 2. So let me just write down first all the elements here. These are the elements we have. At first, majority element, we assume it's 2 at first. Vote is also now becomes 1, or count becomes 1, right? Now, next element is 2. Majority element is, we know 2. So it's still be 2, and vote becomes 2. It will be increased by 1. Next element is 3. Next element is 3. But as soon as this is not my majority element, this is not same as we have my majority element. So what we do is majority element would be as it is, but we decrease it by 1. We decrease the vote, right? We will not take that for every element count 2 as well as if 3. Then majority element becomes 3 and count for 3, that is 1. Then count for 3, that again 3 becomes 2. Then count for 1, it becomes 1 and 2. No, for every element we will not count. Okay, that would be lengthy process, right? We'll take only one count itself. If the same element we get, increase it by 1. If different element you get, decrease it by 1. Okay, let's see. Next element is again 3. Majority element is 2. But decrease it by 1, so it becomes 0. Now, as soon as it becomes 0, means it cannot be majority element. So, till here we are done here. So, if it gets 0, means definitely it is not a majority element in this array, definitely. Because if I am having this 4, 2, 2, 3, 3, 4 elements here. To be an element, a majority element, that element should present 3 times at least. And if you got 0, then it was like, again we have done here 1 plus, again we have incremented plus, then it's 0. So it becomes the known majority elements are also equal to this element. That's why we got 0 ultimately. Otherwise, at least we got 1, not 0. We cannot cancel out the majority element if this is the majority element actually. But here in this, within this array, it's not. We can see 2 is only 2 times, but it must present 3 times to be a majority element. So it cannot be majority element, right? So as soon as you go to the next is 1. So now whatever the current element, that would be now the majority element. We consider it the majority element, whatever the current element, and vote is also 1. Yes. Next is also 1. Okay, same as majority element, so it becomes now 2. Vote becomes 2. Next is 2. Current element is 2. Majority element is 1. So obviously it becomes 2 minus 1. We will decrease the vote by 1. Now again 2. So we will decrease it by 1. It becomes 0. Majority element was still 1. And current element is 2. Current element is 2. We still are having one element 2. So if it becomes 0, the majority element is 1, but the voting is 0, so it cannot be majority element. Right? Till here we done. Till here we done. So whatever the next element, whatever the current element you will get now, that would be the majority element. So now at last we are having current element is 2, majority element would be 2, and occurrence of that would be 1. And if you move, okay, it's out of the array. Stop here. So at last, whatever majority element you have, here we are having 2. That would be for sure, that would be the majority element if exist. And according to the condition, according to the given question, there would be majority element. You can assume that, yeah, there would be majority element. So here in this case, 2 is the majority element. And you can see here, 2 is the majority element. But still, if there are chances that majority element may not exist. So what we can do, at last in majority element we get 2. Okay. Now count the number of occurrence 2 in this array and just consider, just check if that count is greater than n by 2. Then majority element is that. Otherwise, you can just return majority element doesn't exist. That's it. Yes. But if majority element exists, if that is for sure, then whatever majority element you have in this variable at last, hello, that would be surely the majority element. Right. So this is the, you can say, voting algorithm, Moore's voting algorithm, and it's really important to find out majority of elements. To find out majority element, not majority of elements, majority element. Now this approach, how to write down this thing. Let me show you. So at last we are having this 2 and majority this, we are having 1. It's not 0, it's 1. Yes. At last it would be something 1, 2, 3, and whatever element you have, that would be the majority element. Now how to write this thing? Obviously, we need a loop from 0 to n minus 1, that is for sure. Right. Now let's consider at first majority element was 0 and vote or count will also be 0. So now we will check. But we'll not simply say majority element is equal to the first element. No. Whenever count or this vote is 0, then only whatever the current element, that would be the majority element. So you first see if count, or sorry, we are taking here vote. If vote equal to 0, then only majority element would be whatever the nums of I. At first also vote is 0, right? So whenever you go I is equal to 0, it's 2. Vote is 0 at first, yes. So the first element would be majority element. Yes, it's true. It will be applicable in every cases. So this is to consider this. Now how to, when to plus plus, when to minus minus this vote. If my majority element is equal to whatever the current element, whatever the nums of y. If this is the case, then we will do vote plus plus. Else, we will do vote minus minus. That's it. Simple. This is what you need. That's it. And at last, simply return whatever is there in this variable majority element. So you can simply return here, return ME. We are taking here ME. So ME. That's it. Simple. You can take this. I is equal to 0 at first. See, I is here. Condition true because length is 9. So condition true will enter here. Vote 0? Yes. So ME right now. Majority element is 2. Now check. If M is equal to nums of I, majority element is 2. Nums of I is equal to also 2. Yes. Then vote plus plus. Now what becomes 1? Yes, will not go to the else part. Now I plus plus. Now I becomes, I is here, 2. Again it's 2. If vote is 0, then only this would be the case. But right now vote is not 0, vote is 1. So this condition will not enter here. Now check the next condition. If my ME, majority element is 2, is equal to nums of I is right now this. So nums of I is equal to this. It's equal to 2. Yes, vote plus plus. Now vote becomes 2. I plus plus. Now I is here, 3. Is vote 0? No, vote is 2. Is M is equal to nums of I? ME is 2. Nums of I is 3? No. So go to the else part and vote minus minus. Now vote becomes 1. Yes. Next, I plus plus. Now I is here. Again 3. Is vote 0? No. Is M is equal to nums of I? No. Else part. Vote minus minus 0. Yes. I plus plus. Now I is here. 1. Is vote 0? Condition is still true. So we'll enter here. Is vote 0? Yes. This is 0. So now ME will become, ME will be nums of I. Nums of I is this one. So ME is now 1. Majority element is 1. Now check if. This is also if, not else. If ME is equal to nums of I. ME is 1. Nums of I is also 1. Yes. Vote plus plus. Vote is 1. Right? Again I plus plus. Now I is here. Is vote 0? No. Is majority element equal to nums of I? Yes. Both are same. Vote plus plus. It becomes 2. I plus plus. Now I is here. It's 2. Is vote 0? No. M is equal to nums of I? No. Sorry. M is equal to nums of I. In this case, M is equal to nums of I. M is equal to 1. And right now, nums of I is equal to 2. These are not equal. So, else part. Vote minus minus. Vote becomes 1. Now, I plus plus. I is here at 2. Again, condition true. Is vote 0? No. Is M is equal to nums of I? M is right now 1. Nums of I is 2. So, these are not equal. So, vote minus minus. It's 0 now. Again, I plus plus. Now, I is here at the last. Is vote 0? Yes. Majority of element becomes nums of I. Nums of I is 2. It becomes 2. If M is equal to is this nums of I? Yes, M is 2. Nums of I is 2. Increment vote. It becomes 1. Again plus plus. This condition will not be true. Out and return whatever the ME. ME is equal to 2. That's the majority element. So you need to understand this. You can say voting algorithm. It's not tough. It's just you can say related with real life voting system. That's it. So if you haven't get this, it's okay. You can take a break. If you feel exhausted, take a break, come to this again and start fresh. Try to dry run this, try to think the logic without watching the solution, try to write down the pseudocode and all, and then go to your laptop and run the program. Let's name it majority element 169 and try to first go for the brute force approach. Let's code that. I guess you have done this. If you haven't, let's now pause the video and you write down. Pause the video and write down this approach rather than now watching my solution. So let's now define this method and it will return the majority element. So the return type is int and we are having the array nums. First, let's go for that brute force approach. So for two loop we need this first loop will be from 0 till length of this array. So at first let's set count is equal to 0 and let's set majority element. Let's take a variable. Majority element is equal to whatever the nums of I. We'll assume that this is my majority element. Now we check. Same one more loop will run from I to same less than whatever the length of this array j plus plus. Now check if my majority element equal to nums of j. If this is equal, let's do count plus plus. Simple. Yes. And after this for loop, check if now this count is greater than nums dot length divide by 2. If this is true, return whatever the majority element you are having right now in this variable, just return that. Okay. Otherwise, somewhat you can return -1. And here we can just have a variable result is equal to this. And if we check, if this result is not equal to -1, sorry, not equal to -1, then only obviously we get the element. So we simply print whatever the result is, right? Else you can simply print here no majority element exists. Something like this. So if I run this, let's run this and see. It should give me 2. It's 2, right? But if I change it, let's change it. I'm having this. There is no majority element right now. So it should return no majority element exists, right? So this is brute force approach, but it is taking order of n square. Within the for loop, we are having again a for loop. So nested. So ultimately by reducing, by, ignoring all the constant and all, order of n square. I mean, log big of n square. That's not good. Let's go for a second approach. First, we'll see what, let's just comment out this thing. And comment out these things. Find majority element using sorting. Let's define this. So we haven't discussed right now sorting. There are so many sorting algorithm, but for now we will simply use whatever the inbuilt. So average dot we are having sort. In this we just pass nums. It will give you a sorted array. This nums array would be sorted now. If I write here, we are having here 1, suppose 0 and 2 comma 2, or maybe 3, something like this we are having. So first we will sort the array, right? Now we return the that mid element. So what we do is, let me try to run this within a simple statement, like simple return. So return nums of mid. How to calculate mid? We know it's 0 plus, I hope it works, 0 plus that high divided by 2. So high would be whatever the length of this array, nums dot length -1. So I'll just write down this in bracket again. This would be my high, and then again in bracket and divide by 2. I hope it works. I don't know. Let's see. It returns this. So let's run this. Let's keep it as it is if result is equal to this. Otherwise, you can simply print. No need to check if result is -1 and all. So it's 3. And 3 is the majority of element. Yes, we know majority element. But if I make it 2, so I guess it should work. It should give me 2. Yes, it's 2. But this thing will work if, yeah, there is a condition that there will be always a majority element. But if suppose I'm taking this kind of array, there is no element which is present here and as a majority, 1 2 3 4 5 6 7 8 9. So let's delete it again. So I think now there is no element. But if I run this, then it will give me some value, that is 2. But 2 is not the majority element. 2 is 1 2 3 times, and total number of elements are 1 2 3 4 5 6 7. So 7 divided by 2, that is 3. 2 must be more than 3, at least 4 to be a majority element. But right now you are getting a wrong output, a wrong result. So this thing will work, whatever you have written, that in the case that it always have a majority of element, right? Majority element. Otherwise, you can see if it will return the element which is at mid, then here you can check if that element, let's start from here to here and count how many times that mid element is present in this array. And if that count is greater than n by 2, then only it is, you can say that it is majority element, otherwise not. So you have to modify the code a little bit in that case. I guess you can do it. It will return the element here, the result is the element, and then accordingly you have to find out that element. Same for loop you will run here from here to here, from 0 to length minus 1, right? And check that element count. That's very simple. You have to check if this whatever element at mid is equal to whatever the element in this array nums of I, count plus plus. Otherwise, no. If that at last count is greater than n by 2, yes, it is majority element. Otherwise, there is no majority element exist. Update the code something like this, right? So this is second approach. Third, in third approach, what we were doing is, so let's comment this out first. So we'll be having a function using Hashmap. So let's define this method. So it's a method. So create a map first. So see map, you have to give k and we like two values. So first import the class java.util.map. So we have now here java.util.map. Now both values are integer. Key is also integer and the value or frequency is also integer. Let's name is m only, m, the name of the map. You can take any name. Let's take we are counting. So count map or m or any name you can take, right? So we'll traverse the array from 1 to last, same loop we need. And then we'll fill our hash table or that map. We are using hash table. Hash map use hash table. And we'll store the value in key and value pair. The data in key and value pair, key and frequency. So how to do that thing? What is the value? Value is the frequency, or you can say which value is equal to. We have here count map dot a method gets or default. So it would be nums of I or 0. And then we put count map dot, we have a method put, and here we put what, nums of I, and then we'll do whatever the value is in that plus 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 1, something like this. See, don't worry if you're not getting this thing, we will see hash map later. So get or default, this method in this map.java, in this interface, this is having object key and v default value. So this will return, this method was added in Java 1.8, returns the value to which the specified key is mapped, or default value if this map contains no mapping for the key, right? So for this key, if there is no mapping, then it will return the default value. Default value is 0. Otherwise, according to this key, whatever the value is, that would be returned, right? So that is the frequency value. Maybe frequency value is for 2 it's 1 or 2, then it will return that thing. Otherwise, if no mapping is done, then it will return 0, right? So at first, obviously at first, if you get any element first time, so count is 0, value is 0, and we will just increase it by 1. While putting that number, we just do value plus 1. If 0, value plus 1. Again, if already the value is there, maybe 1 or 2, in voting we have seen, then also we'll do value plus 1. Again, increment it, right? Okay, so this is the thing. This is how we can populate our hash table or that map. Now, You have to traverse through that map and you have to retrieve now. We use an iterator basically. You have to retrieve now the value only. If that value of that key is greater than n by 2, then you return the key, key because key and value pair two things. So what we do is now, see this put will do what? Put method in map or Java. It associates the specified value with the specified key in this map, right? So whatever the specified value, it will associate that to specified key. Now let's iterate it. So for that we are having, so okay, this basically this line will return what? See, let me show you what is this entry. What is this interface entry? It will return the type parameter is k, the type of the key and the value. So it will return, see, the a map entry key and value pair. It's a map entry key and value pair. The entry may be unmodifiable, of the value may be modifiable if the option set value method is implemented, but we'll not go in that much deep. But it is a map entry. Map entry, in that table we are having entry key and value. So it's just that. And this iterator is of type this. It's a map entry, integer, integer. And on count map, we are calling entry set, this method. See, entry set. This method will do what? It returns a set view of the mapping contained in this map. Set view of the mapping. Set view means that key and value pair as a set view, it will return one by one. And one value first would be assigned to this iterator IT, both key and value pair, then second, then third, then fourth, because it's for each loop. Now we check if have to get the value, because we have to check if it dot we have a method get value, this is greater than the length of the array. Length of the array have to find nums dot length divide by 2. If this is the case, in that case we need that key. We need that key. So it will simply return it dot, there's a method get key, through this we can get the key from that key value pair. So that's exactly we want. If it's not the case, then return -1. So let's just for safety purpose write down this in brackets because of precedence and associativity rule. So return -1. But if this is not -1, then whatever the result that would be printed, otherwise no majority element exists. In this case, I guess no majority element exists. So let's run this and see. It will print that thing. Yes. But if I change it, so now if I run this, you will see. Now the answer is, I guess, 2. Yes, it's 2. So now we are using Hashmap, but it's okay if you are not getting this because we haven't discussed Hashmap. So you don't know about this method get or default, what they do, why I'm writing map.entry and all, because I'm not able to give you a detailed idea about this Hashmap right now because, okay, it's not, it would be now lengthy video. It's not that thing. You can skip it. Okay. Once we discuss Hashmap, you will get this thing. We'll discuss again this approach. But for now, you can skip this. But if you get it, if you have any idea about Hashmap, you can try this out and it's not that much tough. Right? Okay, this is the third approach. But we are taking extra space here for map, creating map that is order of n. But I want space complexity order of 1. Now, the most optimal approach is let's vote because we want majority element. So we do what? Let's just comment out this thing and
If
now
I
a second
make
method
2 as
find majority element using voting algorithm. Okay, fine. Let's define it now. So let's code this. Coding is not that much tough. I mean, for that, the logic is little bit maybe difficult for you to understand. We are doing plus plus, minus minus, and all this. But trust me, it's not that much tough. Give it some time. At first, what we do? Let's consider majority element. is equal to at first 0 and count or vote is equal to again 0 0 at first. Let's iterate the array. Okay, my bad. It should be array. Int array. So it's array dot length and I plus plus. Now check. If the count is 0, then only we do what? Majority element is equal to whatever the current element right now. So current element, how you get? It's very simple. Nums of I, that's it. Now check. After this, if. Now we'll check. If my majority element equal to whatever the current element, sorry, not null, whatever the current element right now I have, then simply we do count plus plus. Else we do count minus minus. Simple, right? And at last we return whatever the majority element we are having. That's it. It's that much easy. So if I run this, so majority element is there. Let's run this now. In this case, it should give me 2. Okay, it's giving me 2. Fine. If I change it, now I have this thing. And if I run this right now, there is no majority element. So it should give me, it is giving you 1. So it should not be the case. Yes, it should not be the case. But this thing will work only if at last the majority element, at last it will give whatever is the majority element. But maybe, obviously, if there is no majority element, then also we will get something na, in majority element in this variable for sure. But this is the situation when the shorty is given in the question that yeah, majority element exists. But if this is the shorty is not given, in that case what you do? Now there is no majority element here. Now I have, from my this voting algorithm, I have majority element, but now you have to check explicitly the count of this majority element in this array. If that count is greater than n by 2, yes, it is your majority element. Okay. So how to do that thing rather than writing this thing? Now we check. At first, let's take again like any variable you can take. C is equal to 0 or count is equal to 0. And you have to iterate through the loop to check obviously the number of count, how many times you have that element. So nums dot length and I plus plus. And it's very simple. If we check if my majority element, whatever is returned. So okay, the name is result. If result is whatever the result or majority element my method has given me, that is equal to my nums of I, then I simply do my C plus plus or count plus plus. That's it, right? And after this, I'll check if my count is C variable is greater than the length of the array, nums dot length divided by 2. So let's keep it in bracket. If this is the case, then only I can just say that yes, I can just print the result and yeah, this is the majority element. Something like you can check majority element is result. Else, no majority element exists. I hope it works. Let's see. So right now it should give me no majority element exists. Yeah, that's correct. And if I change it to let's make it like 2 is my majority element. I guess we're done. So it should give me now 2. Yes, it's 2. Let's try to submit it. So this is my lead code question. Let's try to submit my code here. This is my method. Let's control C and control V, int nums, same element I'm taking nums. And yeah, it is returning the majority element. So we don't need to check if and else because you may assume that the majority element always exists in the array. So this is the given condition. So let's try to run this and I hope it works. Yes, accepted every test case and it's submitted and that's it. This is the, let's say, optimal approach I have submitted only, not the brute force and all. Right? Let's go for the next one. Okay, ठीक है ये देखते हैं. Okay, the previous one was remove element. So let's try to submit the code here for the that thing also, remove element. So the code was, I guess this. Let's control C and control V. Nums and val, same variable name I'm taking. Nums array and val this and return K. So let's try to run this and see. I hope it works. Yeah, we got it accepted and you can submit it. So like this. You got it, right? Time complexity for majority element is order of n. You can analyze here from here. And space complexity is order of 1. That's exactly we want. That's exactly in the description I guess they have given. Linear time and order of 1 space complexity. So we have one more LeetCode question, but this is for your assignment. You have to practice it. Contains duplicate, the LeetCode question number 217. The given question is, now you have to find out if from a given array, return true if the value appears at least twice in the array, and return false if every element is distinct. Every element is unique, distinct, so return false, otherwise return true. Here, 1 and 1 duplicates are there, contain duplicates or not, so it will give you true. 1, 2, 3, 4, there is no duplication of any element, all elements are distinct, so it will return false. It's not tough. See, the level is easy one. So same, think the brute force approach at first, then optimal approach and something like this. Because till now we have discussed so many LeetCode questions and you are aware about something, like which type of question is there and how to follow, how to approach a problem, how to think brute force solution. I hope a little bit you got it. So at least you try out, right? Brute force is, I guess, very simple here. Just count. Everyone can do that. Just count. Take first element, count how many times 1 is there. If it's greater than 1, if 1 is 2 times, then definitely duplicate is there. And if this is the case, return true. But for that, you have to count for each and every element. Same n square nested loop you use. If you optimize it a little bit, what you will do? We can just sort the array. Okay. See, if arrays are given, and so you can think one solution is first sort the array. It would be little bit optimized. Obviously, sorting is also taking some time. Best sort will take order of n log n. Yeah, that's true. But still, it would be better than n square at least. Right? So you can sort it. After sorting, it will become 1, 1, 2, 3. So if duplicates are there, that would be at one place. So rather than checking this, we can just check the adjacent pairs. Start from this and check the next element with this. That's it. If this is same, then a duplicate exists. Return true. Otherwise, check for everything right now. This. So for the next pair, this. Next pair like this. You check the two adjacent elements. That's it. Like this, you think about some optimized approach. So now, but it's for your assignment. I'll not tell you this thing. You have to do this thing. You have to practice. Right? So that's it for this lecture now. Now, from the next lecture, we are going to start next topic, that is linked list in data structure. So now we'll see in the next lecture. Till then, bye. Take care.